Hey there, folks. So, last episode we briefly covered custom logging and how we can add that in so we can pretty much log anything we want to a log file in the game's execution directory. This episode, we are going to start work on our interaction system. So, just briefly cover what the interaction system is going to be. That is going to be things like a player walking up to a door and opening it. It's going to be things like walking up to an item on the floor, picking it up, adding it to your inventory, and all that sort of behavior. So, really, it's anything where the player character interacts with the game world in some form or another. Open a door, pick up an item, things like that. So, to start with, we do actually need to add some C++ code in. So I'm going to pull over the content browser here. We're going to go into our C++ project file, public interface, and we are going to create a new interface here. Scroll all the way down to Unreal Interface, click Next. We want to make sure it's public and in the interface folder. And then this is the interaction interface. We're going to create that. Now, because as before, I'm running the editor from the launcher, not through Visual Studio. This is going to take a moment, and then it's going to ask to reload the project. And we're also going to end up with the live coding running. However, for the time being, just about done there. For the time being, I'm going to run through a couple of things we're going to be doing with this. A very common practice for interaction is to use ray tracing. And we actually will be leveraging some ray tracing with that, with this interaction interface. But a couple of bits of information. So ray tracing, what that is at a very high level, this is a very basic description, is it takes a point, in this case, point from the camera, and it does a line directly forward, or you can have it go off at different angles if you wish, but you go directly forward a certain amount of distance, and depending on the type of ray trace you have, be it a single or a multi-line, the first object it hits, it's going to report, okay, I hit this. In the case of a single, in multi-line, it will report every object that it hits between those 2 points. Now, that ray trace is done every frame. And that can actually get very taxing on a system if you're running a lot of ray tracing. And if you are doing a lot of traces per frame, be it multiple from one actor, or it's multiple actors all ray tracing. So I'm actually going to cancel the live coding here. We don't need that. Visual Studio hasn't asked us to reload yet. That's a little weird. But anyways, going back to what I was saying there. So it will, it draws this line once per frame, and it needs to do that before it updates the frame. So it can actually visually updates your frames. So that can actually be a big cause for a drop in your FPS, is having a lot of ray tracing running in the background. So there is one thing we can do to avoid that. And we're going to be using that method within our interaction system. So what we're going to do here, though, is we're just going to close out of the editor for now. And we're going to hop back over to Visual Studio. We're going to start off in our interaction interface. And this one is going to be fairly simple. We don't need to add a lot of functions here. We are going to add in, bear with me, and I found is you can randomly have one of your monitors disable, and you need to redetect it. They try to claim it's bad cables. I know it's not bad cables because my system worked perfectly fine on Windows 10. I updated to Windows 11, and all of a sudden I start randomly losing a monitor. Well, anyway, so back to the actual purpose of this here instead of ranting about Microsoft. So within this interaction interface, we don't need to have many functions. we need, well, right now I have two. So first one, U function, blueprint native event. Now this is something you'll notice whenever I do an interface. I have a native event function, and then obviously, as we did with our save actor interface, we have a code level implementation. And the reason for that is, though I plan on doing everything through C++, as I mentioned towards the start of the series, you need to take into consideration what happens if your project actually goes somewhere and you have more people joining. And you need to get other people working on things, and you don't have purely C++ developers. You have people who only work in blueprints. So you don't want to restrict their functionality because you only work in C++. You want to be able to use both C++ and blueprints. So anyways, now that that's over, so void interact, we want to pass in a character reference, or a pointer in this case, to the caller. And I'll explain that once we get into what we're actually doing with this a little later on. And then obviously we're going to go implementation. And then we're going to have pretty much the exact same thing here. We're going to have blueprint native event U function, bool is interactable. This is going to be a constant. Now this one we could get away with not returning using a implementation method, but it's better to be consistent. So now we've added those two in. We're just going to wait through. Let's pull this up. Where is Unreal Integration Tools? It is still running. Let's try build quickly, see if that fixes that. Because it's saying this generated header file isn't present. It's probably because we stopped the live coder partway through. So, but anyway, so just to go through a little bit of what we're doing here is this interaction interface that we're created, we're actually going to be using it as a trigger to enable our interaction behavior on the player character. We're also going to be using it obviously to perform all the interaction behavior as well. And I just realized I missed adding a function in here, but either way, I'm going to let this build, and as soon as the build is done, I will be back. All right, so the build went through. It failed, obviously, because we don't have the definition created for these two. IntelliSense isn't providing those to me. So what we do in a case like this is we just quickly go, okay, let's take a look at our... That's because the project never reloaded. Okay, bear with me 1 second. We'll get that fixed. So we're going to close the solution. You can see I have a ton of different ones here. Most of these don't even exist anymore. Let's reload the solution. And this is something else you may find as you're working is Visual Studio doesn't always reload. Here we go. We can see now we have it in the interface filter. It's going to take a moment for the Unreal Engine integration to run through. Normally I don't have this within my videos. I have everything pre-set up, but this is a good example of stuff to actually show you guys of what can go wrong, what can happen. So now that we've reloaded that and this is all being parsed properly, we are getting our notifications. So we can just go through quick action to create the definition. And that's all we need to do here. These are perfect for the default. Actually, we want this to default to return true. So now I had mentioned we missed a function. I'm going to add that in quickly. So again, another U function, blueprint native event. I'll clean up my code here, and this is going to be an f text get interaction text, and then the same thing again with the implementation. So now the reason we're using f text instead of something like a string is text within Unreal Engine can be sort of think how do they describe it? I can't remember what Epic's terminology for it is, but it can be translated into multiple languages. So you can have like a text lookup table of this is text ID 123. In English, it's pick up. In whatever language, I don't speak another language fluently enough to know what that would be, but and then you can have it translated into multiple languages. So what we're going to do here is just add in a why are you not going to work? What are you saying? We'll just have it return just f text. So that is the basic interaction interface here. We're going to get moved on to the next part. So as I mentioned, we don't want to be ray tracing constantly. We want to only ray trace when we know we need to. So what we're going to do, we're going to hop over to the player character to start with, and we're going to add in a sphere collision. So now what this is, you've seen it in game more than likely. It is a sphere component that is basically a trigger volume around the player. So actually we're going to grab this, minimize my inputs for now. Class uSphere component pointer interaction volume. Actually, no, we'll call that trigger for the purpose of clarity there. And then we need to actually add in some on overlap begin and on overlap end overrides for this. So these are going to look a little complicated when we define the functions, but I promise you they're not that bad. So down here in the public section, U function, they don't need any attributes, but they do need the U function decorator. So the first one is void on interaction overlap begin. Now the naming convention here isn't required to be specific for the function name. However, you want it to match what it's doing at a logic level. Simply because, again, for code clarity, you want somebody to be able to read that and go, okay, that's for when, actually will even be on interaction trigger overlap begin. Now I'm actually going to copy these instead of trying to type these out because these are quite a long list for this one. So in here, these are just the default. So it's the primitive component overlap component, actor other actor, primitive component other component, body index, B sweep from, const hit result, sweep result. We'll get an extra brace in there we don't need. So that is the input parameters that were required for a begin overlap. And now we need to add in the end overlap. U function, again, we need the decorator. We don't need any attributes. Void on interaction trigger overlap end. And again, I'm just going to copy these. It's nowhere near as bad as the other one. I just don't want to spend forever typing these out. Similar overlap component, other actor, other component, other body index. So finish up that declaration. and we're going to create the definitions on these. So before we start adding any logic here, we're going to set up the actual calling of these functions. So what we need to do here is this is going to be in the constructor. We need to do a couple of things here. So first of all, we need to actually assign that interaction volume. So interaction trigger equals create default subobject use sphere component, and this is going to throw an error because we're missing the header. I will add that in a minute. Interaction trigger volume. Actually, it might already be included. Capsule component. Well, we'll find out in a moment here. That is working, but it may throw an error when we go to add the overlap setup attachment. Yeah, there we go. It's throwing it here. Incomplete class. Yeah. Okay. And game engine, I believe, for these. No, components. Okay, so just up here, include components. Casing is important. Sphere component dot h. I spelled that right? Component. Yeah, I'm just gonna. Where's capsule component? Why is it not liking that all of a sudden? Is it doing something? Can't just do that. Use of commands. Cannot open source file components, but it can open. Okay, let's just go to open containing folder. I'm going to pull this over here just so everyone can see. Sphere component. So it is there. Why are you not wanting to open that? Let's try up here. Just to see, include components. There it is. I have no idea what was going on there. Visual Studio was having a moment. It's probably because I couldn't type things properly the first time. But okay, so now that header is there for including the sphere component. You can see our setup attachment is now not throwing an error. And all this is doing is it is saying keep the interaction trigger attached to the root component of the player character. And then now we want to go through and go interaction trigger, because otherwise this is going to be pretty small. Set relative scale. Set relative 3D scale. We want that to be a vector, and we're going to just go for a nice round 10 across the board. Now we do need to add in these overlaps, begin and end. So interaction trigger on component begin overlap dot add dynamic. Now you're going to see here IntelliSense is prompting you for the underscore internal underscore add dynamic. You do not want that. You want to just add dynamic. It's actually a macro that's being used. It's not a function. So in this case, we want to add in a user object. Well, that is this. And then the function name is, where we go, ATF player character on interaction trigger begin overlap. Now we want to do the same thing for the end overlap. So it's interaction trigger on component end overlap dot add dynamic. Why? Oh, that's right. Why is my brain saying that doesn't look right? And then the same thing this, and again a TF player character on interaction trigger overlap end. And what these two lines are doing is literally just saying, okay, when the begin overlap event is triggered on this interaction component or interaction trigger, make sure to call this function. And when the end overlap, make sure to call this function. So we're going to just build this quickly, make sure nothing is failing. Everything should be good at this point. While that is happening, though, I will run through some of the other stuff we're going to do. So the whole purpose for this interaction trigger, as I mentioned, is to enable and disable the ray tracing. Ray tracing is resource intensive on the machine, and yet fair enough, 1 or 2 ray traces aren't bad. However, I like to approach everything from the start of a project of we don't want to do it unless we have to. Without going into a huge detail about my background, where I work, it is important that we are as resource efficient as possible with our code. So habits from my professional life boil over obviously into my hobby development work. So with that though, what we are going to do, we do need to actually add in another include here. So this is going to work, but let not close out a caps component. I'm just going to grab it from here. Now it is building, so we can't save anything right now, but what we're going to be doing is down here is if other actor implements oh, my brain's melted. Is this I interaction or U interaction? U interaction. U interaction interface. Close that out properly. Okay, so just like we were doing with our save in our game instance, we want to use the negative context here. We just want to return. Wow, I really cannot spell. And we can copy this little portion here as well and throw it down here. So what this is doing is this is quite literally saying if the actor doesn't have the U interaction interface, we don't care about it. We're going to ignore it. Again, code efficiency, this is just a case of we know we do not want to do anything with this, so let's just drop out right away. You could add in or have your code like this, where it's if it has the interface, we're going to do stuff. But the reason why you don't want to do that is you can then add more stuff down here and potentially, or you could have like an well, you could have anything down here really, and this could go, okay, it doesn't implement this, but we want to do whatever logic is down here. The whole reason for using this, if it doesn't implement the interface, drop out, then we know, force a habit, hitting save, we know we cannot do anything with it. We don't care. Don't waste any more time. So, however, if it does have the interface, we need to do a few things with it. So, well, first of all, we need to say we need to interact. Well, we need a flag for that. So up here in our private section, we are going to U property. We are only putting the U property on it because I want it to be something we can see in the editor. And this is just for the purpose of showing you guys. But you could leave this without a property and just be 100% C++ code. We want bool B should enable ray trace. Actually, not should. B enable ray trace equals false. Nope, can't save. So ultimately, okay, now I can. Project built with no issues. So, okay, so here we just want B enable ray trace equals true. And actually, no, that is not what we want to do. Sorry, because we could have multiple actors in there. Sorry. There's a second portion to this, and we're going to do the same thing. T array A actor pointers interactable actors. And then, so interactable actors dot add other actor. And in here, we can just say B enable ray trace equals true. Now, it's down in the end overlap. So what we want to do here is interactable actors dot remove other actor, and then B enable ray trace equals interactable actors dot num greater than 0. So just to explain what we've done here, so we're adding it to an array, and we know we've added something to the array. It's going to always have at least one member. Just force it to be true. We don't need to do any logic. We're good there. Here we're removing it from the array, and we're saying if we still have more than one actor in this array, we want it to continue ray tracing. If we don't, turn it off. So now that we have that, we need to worry about our actual ray trace functionality. Well, let's add a private function for that. Yeah, sorry, just making sure everything's right there. So we want void trace for interaction. We're going to create this definition. And now, well, as I've mentioned before, earlier in the episode actually, ray tracing happens per frame. There's something else that happens per frame. That is tick. Where is my tick function? Do I not have a tick? I don't have a tick on the player character. Oh, that's why it's on the character, isn't it? Begin play, jump. Yeah. Okay, so we do need to add that to the player character. So let's just grab that. Virtual void tick override. It's a public function because it's called by the engine itself. Does not need a U function declaration or anything like that, as you can see here. Going to create a definition. Now, if B enable ray trace for interaction. So what we're doing here is does not have a tick type. I'm going to look something up here quickly, actually, because I thought these had tick type. So, UE5 C actor tick function. And yeah, so this is, you guys will see that I'm trying to find the actual, this is the one. Now does it cover it in C++? Actor spawning can tick, be tick even when paused. Come on. Nope. Actor tick type. Does that get me? Well, we'll just leave it there, and we'll actually do it up here. And let's go to, I think the character is going to have it. Primary actor, that's the one we want. Primary actor tick dot can ever tick equals true. Primary actor pause equals false. So this may just be me misremembering things because we spent so much time working on components, but I swore this could also be handled within the tick function. I may be wrong. But anyways, I digress. So what we're set up here is every tick, if we should be ray tracing, we're going to trace. Well, we're going to call the trace function. And that is all derived by the fact we may or may not have actors within our interaction radius. So the next step is to actually create this trace for interaction logic. So we're going to minimize all of these. Yes, I know there is keyboard commands for that. However, I have keyboard commands for OBS that I don't want to potentially overlap. So up here in our trace for interaction, we need to actually, as I said, trace that. So we're going to start with F collision query parameters, I believe. Collision, if we could spell query params, there it is. Line trace params equals F collision query params F name text interaction trace. We want this to be bool trace complex true, false. We want this to be true. Ignore actors, cons actor, ignore actor. We want to include this. So what this is saying here is the name. This is just for debugging purposes. We're actually going to show that shortly. Complex trace, that is at a really high level. As I was mentioning, it's either do we want to trace multiple different objects, things like that. There is a lot more to it, but at a very basic level, that's complex trace. And then the ignore actor. We do not want to hit ourself because we don't care about ourself, like as in the player character. We want to exclude that because otherwise the way the line trace is going to be set up, at least initially with the third person camera setup that we're working with, it's going to hit the player character and it's going to detect the player character, and that's a wasted trace. So now the next thing we want to do is lt params dot b return physics material, or physical material, sorry, equals false. We don't care about the material. Lt params dot b return face index, we don't care about that. And this is just reducing the amount of work that the line trace is doing. We don't need it to return either of those bits of information, so don't waste cycles on that information. So now we need an F hit result, and we're going to go line trace hit, and we are going to force init, force initialize. Now we need a starting point, so we need F vector LT start equals follow camera, because that's where we want to start from, is the camera itself. Get component location, and then we need to get an endpoint. Sorry. However, we want that to be a distance forward. One thing we need to account for is the fact we are running on a camera boom with our third person camera. So if you're up against a wall and that boom has been shortened by the collision trace, it's going to have a dynamic length. So we need to account for that. So what I like to do for this, and it is not 100% efficient, but float search length equals get camera boom length. Do I have a function for that? Get camera boom dot arm target arm length. Is that the one? No, I created a helper function for this. That's why. Equal. Okay, so this is a, I'm not going to do a helper function for this one because it's a little weird, but it's follow camera get component location minus camera boom get component location. Dot length. So just to explain this quickly, so the camera boom's location is where it is attached to the root object. I believe the camera boom's hooked up to the root object, isn't it? Camera boom, yeah, so it's where the camera boom connects to the root object. That is its location, not where the camera is. And the follow camera's location is where it is connected to the camera boom. So what we've done here is we're just getting these two, subtracting them from each other, and getting how long, like how far apart they are. So that's our search length. Now we do need to also add a little bit more to that, because otherwise you're going to trace from the camera to the camera boom. So what we want to do here is on the player character, we're going to grab this value here, or the U property there. We're going to edit defaults only, float interaction trace length. I'm going to set that to a value of 200 by default, just because I know that's what's worked for me in the past. Grab that just for ease, go back here. Now you could also add this here, but I do like to, as I've mentioned in the past, use the KISS method. We're defining the original search length here. I don't want to overcomplicate the math. I'm just going to go search length, and I have to fix that spelling, plus equals interaction trace length. And rename, just because that annoys me. Preview, apply. It's only hit those 2 points so far. So we have the search length. And this is, like I said, it's the distance from the camera to the camera boom, or basically it's the camera to the root point of the root component on the player character, plus this additional value. Now we need to actually do the trace. So we need to get world line a trace. Now this is where I was mentioning before of the multi-object single object. What we want to do is, in this case, single object by channel. LT hit start lock. What was LT start? Sorry. LT start. Oh, I actually entirely missed a step here. I skipped over my own code. So we need the endpoint. So we're going to go f vector LT end. And then it's going to be, okay, so we want the follow camera, get forward vector, times that by our search length. And then we also want to add LT start to it. So now that we've got that, we can go back down to our line trace code. Let's get rid of that extra line we have there. LT end. We want to only look at the visible channel, so we want ECC underscore visibility. And then we want to, casing is important. And then we want to LT params. So that's going to create the line trace. And actually, we're going to show that here. I'm actually going to show the debug of this as well. So get world debug, wow, not bedbug, debug line trace, draw trace tag equals this. What this is going to do is this is going to cause your line trace to be visible in the editor. The problem is we have nothing that is going to trigger that yet. So what we're actually going to do, just up here, we're going to default this to true. And then we're going to build quickly. So again, I'll just quickly recap this. The episode is getting close to coming to an end. This will be the first part there. But so what we have here, we are creating our line trace parameters. In this case, defining we want to see it in the world. Then we're actually performing a line trace. Right now, we're not actually doing anything with that line trace information. We're going to do that in the next episode, because we're actually going to have to go through and create a couple of debug actors that implement this interface. So, however, what we will be doing, just to expand on that while this builds, I'll take advantage of the time. What we do from that then is we check to see, okay, did we hit something? If we did, does that actor have the interaction interface? If it does, well, we need to update and present a UI element. So, however, first of all, we are just going to quickly run this. We are going to show what we've done so far, and then I'm going to actually call this an episode. But thankfully, the editor builds pretty quick after I've compiled it through Visual Studio, and I've been running it for a while, so it shouldn't take too long. There we go. Okay, so now with that, we're going to hit play in editor. It's going to take a second to load. And there you go. You can start seeing. So what I'm going to do is hit F8 to eject. And you can see there's that blue bar. That is the line trace that's happening. It's starting here because that's where the camera is, and it's ending there. So if we had hit an actor in that point that is using the interaction interface, we would do some additional logic. Now, just to expand quickly before I end things, the reason we are using let me just pull up the code, a line trace single is if we have two actors, one in front of the other, we don't need to return both. We don't want to be able to interact with the one behind it. You only want the one that's in the front to be what we're concerned with. So in this case, we are only using a line trace single, not a line trace multi. But with that, folks, like I said, I'm going to end the episode here. We have covered the first part of our interaction interface. Next episode, we're going to set up some debug actors, and we're going to start working on the visual display component of that. Thank you for watching. As always, any questions, comments, suggestions, please feel free to leave them in the comments. And until then, I will see you in the next episode. Hey folks, welcome back. So in the last episode, we started working on our interaction interface and just the overall interaction logic that we are going to be using within the game. In today's episode, we are going to continue with that logic. So where we left off is we had generated a line trace. We do want to finish off the rest of this logic here, and then we're going to want to create some actors that use our interaction interface so we can actually trigger this properly. So what we're going to do now is check to see if our line trace actually hit something. So if line trace was LT hit dot be blocking hit. And just like everything else, we're going to use the negative context. We are just going to return. Our line trace didn't hit anything, but if it did hit something, we are then going to see if the, actually we can do that up here as well. If it didn't hit anything, or if it did hit something, and LT hit dot get actor implements U interaction. So what we're doing here is if we didn't hit anything, or if we did hit an actor and that actor doesn't use our interaction interface, we don't really care about it. However, in that case, if we did hit something, we are going to want to interaction interface pointer inter equals LT cast to an I interaction interface LT hit dot get actor. And then just like before, if inter equals null pointer, we have an issue here. We're going to just return, and we can do add logging. Actually, we don't need to do that. We've covered that now. So we're actually going to add that in here. We're going to go include logger.h, and here we're just going to go logger dot semicolon get instance add message, not dot, it's error, add message failed. Something I like to do actually for clarity. Let's go that so we know what function failed. Failed to cast to interaction interface. Error level, and this one is an error. So assuming all of this has gone through, we have an interface pointer, it's all working there. What we then want to do is oh, sorry, I missed some code here. So if we actually want to store a pointer to this actor, so we are going to go back here. We want a visible one, not an editable one. a actor pointer interaction actor, and we want this to initially be a null pointer. We don't want a value there. So back here, and we already know if we haven't hit anything or it doesn't implement the UAction interface, what we can do here is if interaction actor does not equal lt hit dot get actor. Actually, do we need this? It was a yes, that was if we're changing. So if you move slightly, like a pixel to the left, and you hit a different one. Oh, no, I see what I was doing. Sorry. I was looking at old code here that didn't quite make sense. And this is why, like I mentioned in my introductory video, I'm restarting this series with the dev diary basically on that, or restarting the project as this series with the dev diary. Is I'm looking at code that I wrote 8 months ago and it doesn't make any sense to me, or some of it doesn't make any sense. So anyways, okay, so we have got the interaction interface, but we need to do this in a slightly different order. So if interaction actor is equal to null pointer, or interaction actor does not equal lt hit dot get actor, interaction actor equals lt hit dot get actor. And actually, this is where we want to go up here. We want interaction actor equals null pointer. So just to walk through what we've done here quickly, and also basically to make sure it makes sense in my own head, we are checking if we didn't hit anything, or if we did hit something but it doesn't have the interface. We're clearing out our interaction actor because it means we're not looking at something that we want to be able to interact with, and then we're dropping out of the function. If neither of those conditions are true, so we are looking at something that does have the interaction interface, we're checking to see if it is if we don't have a reference, we're going to set it, or if it's a different actor, we're going to set it. Actually, we don't even need to do that. That is a if check we don't need. We can refactor that out. We can just set it directly. We don't need to worry about that. And then we don't need to keep referencing the LT hit. We just use that there. So, and this is some of the refactoring and refinements that I do normally. I will write some code, reread it, and as some people may know, rubber duck debug it. And then in this case, there wasn't a problem, but I'm reading it and I'm like, well, actually, I'm doing a lot of stuff I don't need to do here. So. All right. All right, and then so next thing we want to do is we need to add a function that's going to be a blueprint native function to our player character. We're going to go down here, u function blueprint native event. At least I think this is one. Let me double check. I may have the wrong one here. Oh, my code can be all over the place. Nope, this isn't the blueprint native one. This is a private one. So, what were we doing there? Update pickup text. Oh, that was a refactoring I can do. So yeah, we can leave this as a blueprint native event. Void update pickup. Sorry, we want this update interaction text. So this is something we will be implementing in Blueprints once we get back into the editor. Because that calls toggle, and that is that. So yeah, we do need obviously the implementation version of this as well. Define that. And this is one of the, what are you doing? There we go. And we just want to call update interaction text, the blueprint version. So we have the basic functionality for displaying information to the player character. We do need to add in now a action for interacting with things. So we're going to go to our input section. We are going to just grab any of these U properties because they're all identical. U input action pointer interact action. And then we need to add a function for that. So we're going to go down here, void on interact. And we're going to create that definition. So we're going to add this to the player input component first of all. So we want enhanced input component, bind action, interact action, e trigger event. Now this one, you don't want to use one of the repetitive ones like triggered. You want to use either started, which is when the button is first pressed, or completed when the button is let go. Personally for this, I prefer to use completed because then you can push the button down, hold the button down, move off an interactable item, and then let go of the button, and it's not going to do anything. So this, and then we want a TF player character on interact. So we've added that there. Now we want to add some really basic functionality. So it's if interactable interaction actor is equal to null pointer, return. Now we can potentially refactor this. However, well, and I'll finish that thought before I move on to the don't. We could refactor this and have the interaction actor as a pointer to the interface. I personally don't like doing that, though in theory it should be a more efficient method. I rather not do that and just do the little cast here, just out of my own personal preference. So we want I interaction interface pointer inter equals interaction actor. Actually, we want to cast that, sorry. And we can go fix up our line trace in a little bit, I believe. I think we're grabbing an interface we don't need to. So let's actually fix that up here. So if it doesn't, yeah, we don't need any of this. Actually, before I do that, we're going to copy that because that's actually exactly what we need for down here. So we're going to replace this. And we're just going to fix that logging. So just to explain what I do here with my logging quickly, I just put in, oh, missed the A, the function. So this tells me the class and then the particular function that was called that threw the error, and then the actual error. So anyways, we've got that now. So what we want to do here is inter.interact implementation. And then in this one, we have it's calling. Well, we need to pass in a character. Now, the reason for this, I will only cover this briefly. We're actually going to cover more of that when we get to the inventory component of things. But the reason being is we are passing along the character, in this case, the player character, that is making the call so that the object that we're interacting with, if needed, can say, okay, add me to your inventory. So we're just going to pass in this. And that's all we need to do for that one there. So we're going to build this, make sure we have no errors. And typical fashion, this is taking a little bit of time. So I will pause the video and I'll be back as soon as the build is done. Okay, folks, so the build has finished. You can see everything has succeeded. Also, while this was building, I did go through and actually add a asset pack to my project. In particular, this is the one I added. The reason I added this, as you guys can probably guess already, it's doors. This is a very basic interactable that you can add to a project. And really, it's a core one used in pretty much any game, be it a fantasy game, a sci-fi, modern survival. And this right here gives you a breakdown as to why you get door frames and the individual doors. So you can set these up in a couple of different ways. And that's actually going to be one of the things we cover now. So with that, we're going to launch the editor. And this time around, I'm not going to be launching it through Visual Studio. I'm actually going to be launching it through the Epic Launcher. So hopefully this doesn't take too long to build or to launch. But with that, I'm actually going to pause the video quickly just while things launch, because this may take a little bit as I did add that asset pack in. All right, folks, so the editor did take a little while to launch just because we were launching it from the Epic Launcher and we added in those assets. And just to show you, this is the asset pack here we added in. Apparently match up volume 8 in the marketplace, but volume 7 here. Either way, you can see we have a bunch of mesh. So I just want to check. Let's see, I just want to check something here before I go and delete it, because we don't need the nanite mesh right now. And honestly, these we will probably be replacing. This is just a simple asset pack I could find. Okay, they do use mixed. All right, so I'm just going to leave those for now. Anyway, so what we're going to do here, we're going to open up our project folder. We're going to go into the blueprints, and I'm going to create a new folder in here and just call this dev. I'm going to capitalize that with an underscore at the front so it stays at the beginning. Blueprint class, actor, BP door base. So the reason I'm using this naming convention is I want to create basically a parent blueprint that we're going to use for, well, that in theory could be used for multiple different doors. So what we're going to do here, open this up. And this is, as I mentioned, we could do this in C++, and I sort of want to. However, ultimately for what we're doing here, it's going to be overkill. So the first thing we want to do, though, is we want to go to our class settings. Over in the interface section, we want to add interaction interface. Compile that just quickly so it loads all of that in. And then you can see here on the left-hand side, we have 3 functions, which are the ones that and I'll just bring them up here. the ones that we outlined within our interface. Get interaction text, interact, and is interactable. So minimize this a second. Is interactable, interact, and get interaction text. So static mesh component. This is going to be door frame. Make that the root. And then we're going to add another static mesh. And this is going to be the door itself. So I'm going to do here, I'm just quickly hop over to these mesh. We're going to go for the low poly. And just for ease, we're going to use this single door here. And let me bring this back. And I'm going to move the content browser out of the way. So the door frame, we want to use that mesh I just selected. And then for the door, we're going to add this one here. And this is one of the reasons why I wanted to use this particular one, at least for this phase, is I've used it in the past. If we switch over to rotate mode, you can see the pivot point on the door is where the pivot point should be on a door. You will find there is some assets that they're not created to be movable, dynamic like this, where you'll end up with the pivot point sort of in the middle of the door, which is not the best. So now what we need to do, though, we want to go to the is interactable. We can just double click on that. Actually, we want this one is interactable. So we want to have that default to return true. We don't need to do any fancy logic for this one here, but if you wanted to, you could set up like, oh, is the door locked? Things like that. Get interaction text. Well, we want to actually have open or close, so we need to actually add a variable for that. So we're going to go down here, scroll down, variables, just a Boolean, B is open. And then what we do is drag off here and just do a select text. This is being slow. So connect the is open to the Boolean input for pick A. So what this is if it is open, we want to say close. And if it's closed, we want it to say open. And then finally, we want to double click on the interact. Now, this is going to bring it up as a custom event within the event graph because it's not a function. I'm just going to bring up the Visual Studio again quickly. And we're actually going to go to the header file. It's because this is a void that has no return type. It automatically gets created as a custom event. So what we want to do here, we want to go right-click timeline. If I could spell, add a timeline, and door rotation. Double-click on that. We want to pick our length. We're going to say it's going to take 1.25 seconds. Use the last keyframe. We want to do that. New track. Add a float track. We're going to call this Z rotation. Shift click twice, once to the front, once to the beginning, once to the end. Click the first one, change that to 0. So the time is 0, the value is 0. Hit enter, helps. And then click on the last one. We're going to put the time at 1.25. And just quickly before we finish this off, actually, go over to your viewport, select your door. Make sure you're in rotation mode and then just see, okay, 90, we want this to open to about 110 degrees. So go back to your timeline, click on that last one and set the value to 110. We can close out of that timeline now. Close out of this and this, stay in the event graph. So we want to start off by grabbing B is open, drag off, put not, and you want the not Boolean, which is up here. Then we want to set that. So what we're doing is it's a flip-flop, but for the Boolean. So if this is true, we're going to set it to false. And then we want to drag off a branch. So if it is open, we're setting it to false, which means we're going to be coming through here, which means we want to reverse. Now you can reverse from end, but what that's going to do is if you, and you may have seen it in some games, if your door is partway open or close and you interact with it again, it jumps to the end or the other position and then starts completing that action. So you just want play in reverse. And then in this, going through the other flow though, so if it was not open, we're going to be setting it to true. Set this to true, it's going to come through up to the true. We want to do that. Now we want to take our door, drag off a reference to that, set local rotation. Sorry, not local, relative. Set relative rotation. It's right there. I'm blind. Split your struct. Z rotation goes into here and move this to update. Compile. Now, what we have done here is created a very basic door that can be open and closed. Actually, we want to set this back to 0. That's its default state. And I'm just going to bring that blueprint over. We're going to put it up here on that, and I'm going to rotate the whole thing 90 degrees. Now, we can't actually do anything with this just yet. It's actually not going to work because we do need to work on our third-person character and their input actions. So, bringing the content browser open, we're going to open our input folder. Into our actions, we are going to duplicate the jump just because it is a one push. So IA interact. We are going to go back to our default mapping. We are just going to add in that one we've just added, IA interact. And in this case, now, again, this is going to be down to how you want your key bindings set up. Ultimately, I do want to add in what is the character lean, like the left-right lean, pretty common in FPS, like shooter games. However, oh, I forgot to disable that. However, we're doing a survival game, but so instead of using the more common E for interact, I'm actually going to be using F. We're going to save that. And we just need to hop into our actual blueprint, interact, and just add that there. And for now, I'm going to leave these, the debug at 7 and 9 for save and load, because they are actually going to be useful for us. But so first things first, now we're going to play. You are going to notice we're not going to be displaying any text. That is expected. We haven't set up that portion of the UI. And you can see because we do have that false, the Boolean trigger for should we trace set to true by default. You can see we're here. We're not doing anything. So we're going to have to launch in the editor there. But let's move away. And you can see now that we moved away from that, it's working. We get closer. Oh, I'm hitting the wrong key. Well, that's still not doing anything. So let's stop here. We're actually going to open up that door blueprint a second. And we're going to add a breakpoint on there just to see, does that actually trigger? So I'm going to move that off the screen. And if it does trigger, I'll bring it back. So let's see, we're going to go through, our line trace is there, we have to fix that. Go up, hit F, it is not triggering. So let's check character, here, enter. Okay, it is, we have it referenced, but we're not triggering it. Okay, so let's close out of the editor because we want to run this through Visual Studio. I should have done that in the first place. We'll quickly look over our code just to make sure I haven't messed something up there. So set up player in component, bind action, interact action is on interact. Okay, on interact goes if the interaction actor is a null pointer, return. If the interface is a return. Actually, I'm gonna just while we're doing that. I know why, because we're calling the implementation. And in here, it doesn't actually call anything, so interact. We'll just do that. So this would be why. We're calling the C++ version of the function. Why are you... oh, caller. I need to pass that through. We're calling the C++ version, but it doesn't point through to the blueprint version. So that is, I'm like 99% sure that's why that failed. So we're just going to let this build and launch the editor, and I will be back as soon as that's done. All right, folks, Visual Studio compiled, and we're now back in the editor. Let's actually see if this makes a difference. Now that I've fixed the fact I'm calling the C++ version and not the blueprint version. Forgot to fix that, but that's not a problem. So we'll run over to our door, hop up here, and then hit our interact button. There we go. Now, oh, we got a null pointer. Okay, let's go through. Break that one. I wonder why that's happening. Interaction actor. That's the first time I've seen this particular issue. Maybe it is because it is a blueprint. Okay, so anyways, let's go character. Make sure, I'm just gonna, nothing else. So that is, oh, we've got it in there twice. That doesn't help. Let's see. Goes away once. Put them both in. To check that one. So it does hit there. But we're not getting an interface. So let's look at the blueprint. Well, we've got the interface. Interaction interface. It should be... well, okay, well, maybe this is going to be, it's the first time I've done it using purely blueprints. So I will go through, we're going to go to our C++, public base classes, new class, actor. And actually this is going to go back to our save game, actually, because this is going to be something that is down to your individual project requirements. But for mine, I want the state of a door, whether it's open or close, to be saved. So we're actually going to create a base actor class in the same way we created that base character. And then let me get back into the... oh, this is going to take a moment here. Come on. Open the back up. It's still adding it in, so this may take a moment. But anyways, I will go back to what I was saying. So this is going to be dependent on the sort of game you're wanting to make. I know a lot of games don't save the state of a door, be it open or closed, because that's a lot of information to save for very little return. However, that is something I want to include in my game. I want, like, if you leave a door open, I want it to save that you left that door open. Without going into specifics, because it's something that's going to be much, much later in the series, there's a reason for that. So, okay, we're going to let this live code finish as well, because we want to create a second class here. But to further continue what I was saying, so we're going to create that base actor class, in this case TF actor, which we're going to use to be a parent class that has all of the save game logic on it. And then from there, just like we did with character, if there's anything additional we need to add, we can either derive TF actor or we can spin off something different. So actually, we don't need to worry about the live coding finish because we're going to shut down the editor right away anyways. So no, we do, because we need to be able to make a derived class. So anyways, continuing with that. So what we'll be doing is we're going to create a very quick TF actor base class that is going to inherit from the interface. We are then going to create a derived class of TF actor, which is going to be door base, and that's going to be texture filtering. What we're going to work with for a new door attempt. TF door actor. Nope, we want TF door base. We'll create that class. Wait for this to finish. Hop back over to Visual Studio. Hopefully it says you want to reload. Yep. So we're going to... Can't stop it there while it's running, so we've got to go into the live code, wait, cancel out of this, go back to the editor itself. Okay, move the browser out of the way. Thank you. I'm going to close out of the editor. Yeah, close out. Thank you. We'll wait for Visual Studio to stop debugging. This can take some time, it seems. I'm going to hit reload. And this may take a moment to populate all of this. But the whole purpose for this and the derived actor class is, as I mentioned with the character, it's for things like the stat line. Instead of having to add it to multiple different classes that are all going to be doing the exact same thing with it, you start with your base class of TF character, and then you do a derived TF player character. Then you can also derive like TF animal, so you can have an animal base class, a zombie base class, a mutant base class, a dragon base class if you're doing fantasy, things like that. And then anything that is used by all of the actors or all of the characters goes into the TF character, and then anything that's unique to a particular class goes into their specific. So we're gonna we can get rid of character, keep those two, and get rid of player character here. And we need to open the door files because it didn't open those for us. So we're going to start off just here. We're going to include that in TF actor base. Actually, nope, we don't want to include that. That's in door base. We want to include the save actor interface. And I went to the header when I wanted the source. So I'm going to put this TF actor here. And we're just going to go public save actor interface. Grab those quickly. We need that one. Let's bring these down here. that one. I personally, well, actually, no, you could have runtime spawned actors. So we've got get actor ID, set actor ID, get save data, and then we should have a set save data. Do we not have that? Oh no, because we haven't had to do any custom information on a actual actor yet, so that's why. So we'll go back to, I'm gonna actually close these all out. We'll go to the actor. So up here, we just want to add fguid save ID. Go into here and just go save ID equals fguid new GUID. And same as we did with our TF character, if save ID is valid, change that to not, save ID equals fguid new ID, new GUID. And we'll create these implementations quickly, or definitions, I should say, implementations. Talking and reading at the same time does seem to mess with my brain a bit. Did I already create that one? No? Why are you not letting me? Oh, that's why it's missing a semicolon on the end. Okay, so we want this to be return save ID. And then same as before, if save ID dot is valid, save ID dot invalidate, save ID equals new GUID. Now, right now, we don't have anything we want to include with the get save data implementation, and we're just going to leave this one basic because that is going to vary from child class to child class. So we've got the very basics here set up for the TF actor. We're going to save that and close out of these. And now we're going to add the door setup. So we've got that in here. So we want public interaction interface. Add these in quickly. So private, just because I know we're going to have some variables there we want, and public. And finally is interactable. So we're going to quickly define these. Okay, so right now we're just going to, again, default this to return true. For this one, we are just going to call the interact with caller because, again, this is something we're going to do through blueprints. I personally hate trying to do things like timelines through code. It's simply easier and more elegant to do it at a blueprint level. So we'll deal with the get interaction text though. So we're going to add in a U property visible anywhere blueprint read write save game meta, no, it's a lowercase meta on this one, equals allow private access equals true. That's actually an inconsistency I dislike here. Meta is spelt with a lowercase. However, where is it? Save game. Save game? Nope. Save actor interface. That was it. Oh no, that was the stat line. Sorry, I forgot where I'm putting enums. where I've put enum so far. If we look here, UMeta, it's all capitals. That's just personal preference. I dislike how name convention isn't consistent through everything. Anyways, I digress. So we want this to be a bool. B is open. We're going to say false is the default state. So now we have that. We can go back to this class here. Class this function. B is open. If it's open, we want it to say close. And if it's closed, we want it to say open. Const char f text. I can never remember how you declare text. F text. From string. That's it. So just to quickly run through this, I actually need to go through and create a constructor as well, but the way we set up here is if the door is currently open, so if this is true, we want to return this value, close. If it's false, we want to return this value, open. Let's just create a constructor real quick. We don't primary actor tick can tick can ever tick. We don't need the door to tick, so we're just going to set that to false. And that is also something I would recommend doing. You can do this both through a code level and through blueprints, is if your actor does not need to tick, and what that is being in, like, the actor does not need to be told every single time the frame has updated, turn it off. The fewer of those that are around, the better. It is far more efficient. So let's build the project. And I know this episode is running on a little bit, but I will finish this up before I end the episode. So what I'm going to do is I'm going to pause things here, and I will be back as soon as this has built and I've launched the editor. All right there, folks, we're back in the editor now. So first thing we're going to do, just for ease, I'm going to delete this from the scene. We don't need that. Save the scene. And then we're going to go over to our content browser, going to go into our dev blueprints, and we're going to delete this one here. We don't need that. Yes, it's referenced in memory. However, I removed it from the scene, so that's not a problem. Blueprint class, all classes, TF door. Select that, and BP door base. So I'm going to try this again. Open it up. Same thing as before, static class, or static mesh. That is the door frame. Static mesh, and this is going to be the door. Let's save variables. Why is it? Is open. I thought I had that set to blueprint read write. Did I put read only? Oh, door base. No, blueprint read write. Oh, there we go. Yeah, that's a weird one. It's not here in the variables on the left. It's not editable in the details panel because it's only visible anywhere, but we can get and set within this. So go back to the viewport. I'm just going to move content browser out of the way. I'm going to use the exact same door I used last time, the low poly mesh. Bring this back up, door frame and door. Actually, I'm going to just compile and save this, and then we're going to see if we're running into the same issue as last time. Rotate this 90 degrees and play an editor. I will fix that. But, okay, it's F. Okay, interaction actor is the door. We've got the interface this time. So it was something with how we were casting to the blueprint to get it. It might be this. I actually have never worked with that before. I'll do some digging on that between episodes just so I can see if I can figure out why. But anyways, we're going to continue here. So do not directly call event function in interface, call execute interact instead. And that is where close that. That is in here. And that's this line. So it's enter. What we want is enter, execute, interact. This. That's why. All right. 2 few arguments, and I think it's this I actually need to call. U object. Comment that out, save, minimize this. So we're going to go back here. Actually, because we're going to do a live code update, I'm also going to player character header file. Enable ray trace. This is going to start as false. Just to fix that now. Back to the editor. We're going to do a live code update. This should not take too long because there's only those 2 minor changes to the player character. Apparently 3, but that's because it's the game mode is referencing that character. Successful. Okay, so we're going to go back to our door blueprint now that we've done that. Interface is interactable. We're returning true. Get interaction text. Get That is open. I'm just going to set it up here as well, just in case. Now, right now, we don't need to worry about that if it's open. So, yeah, we want this as open. And if not, we want that as close. This seems backwards to the way we had done it previously. So if this is true, we want it to be closed. If it's false, we want it to be open. All right. And then the interact, which should, there we go. So close out of these 2. Is open. Get is open. Is open. Set is open. Not Boolean. Branch. And we want timeline. I probably could have just copied this over for ease, but door rotation. If it's true, we want it to play. If it's false, we want it to reverse. We want to go in here. We want to set this to 1.25. We want to use the last keyframe, float track, Z rotation, shift left click, shift left click. The first one wants to be 0, 0. And the second one, we want it to be 1.25 and 110. Compile that, close out, and then we want door, set relative rotation, split this struct pin from the update. We want to bring that over, compile, save, close out of that. I do apologize that it seems I am in a bit of a rush. Just this episode is running a little longer than I'm used to, so I want to try and okay, so there you can see we got close enough. The line trace starts and it stops as we get away. We get to the door, we hit F, and Oh, we need the interaction actor. So yes, this is why. So with that though, folks, actually I'll quickly cover this issue, but we're going to end the episode here shortly. So I'm just going to stop debugging. We're going to go here. So this is the one I was messing up on. It needs to be that. So we're executing interact on this door, and we're passing through the collar. So as I said though, folks, I'm going to end this episode here. Thank you for watching and putting up with my insanity in this episode. I know I've been a little all over the place. Next episode, we're going to finish up the last of this interaction and hopefully get things working where we actually see that door opening and closing. But thanks again, everyone, and I will see you in the next episode. Hey there, folks. So last episode, we tried to actually set up the interaction interface in-game so that we could interact with the door. Through a few simple mistakes on my part, just because it's been a little while since I've worked with any of this, I didn't actually get the door up and working. We got very close, but we had ended off with me calling the interface incorrectly. So with that, I've gone through and fixed that there. We're going to quickly build this project, and hopefully this won't take too long. In the meantime, that built. We're going to launch the editor again just to make sure. Launch the editor from Visual Studio just to make sure we can debug. But in the meantime, I have done a little digging. I still haven't come up with an answer as to why, when we were using a pure blueprint class, this was failing, the casting to the interface. I do still need to do a little bit more digging into that just to make sure and see if I can figure out what is actually going on. I will try and provide an update at some point. However, in the interest of keeping these episodes going, I didn't want to waste too much time digging into that just yet. So anyways, because we stopped the editor without saving it from our last one, the door itself that we had created last episode didn't get saved. It's gonna that's gonna open that way, so we want it to open away from the character. So I'm gonna save it this time. Now let's try this one more time. So as you can see right from the start, that line trace isn't happening. We're going to get closer to the door, and it's right around here. You can see the line trace starts happening, and that little red dot is where the line trace hit. So we're up here. We're going to hit interact. Okay, so the interaction actor is the door. We did successfully get the interface, and we called execute. Oh, there we go. So obviously, because that breakpoint, we missed it. So let's stop that. I'm going to get rid of that breakpoint so we can actually see this working in real time. Drop it to the editor. We'll go back in here. All right, so let's run over. We'll get our line trace showing up. We'll make sure it's hitting the door, and we'll hit F. And there you go. You can see our door open, and we can walk through. And this particular door, it's still collision blocking. We'll hit it again, and the door closes. So now, depending on your game, sometimes you may want to display pop-up text, like a little helper text for the interaction event. The one that comes to mind for me is like Skyrim. It pops up a little thing, pick this up, open this, close that, search that. So we did start adding some of that functionality in, and I'm personally up in the air as to whether I want that in my game. I'm actually thinking I might make that a configuration item, which is configuration items like that is something we will cover much later in this series. We're still working on the very foundational aspects of the game. But anyways, for that help text, so we can use that at least for debugging, what we're actually going to do, third person character, blueprints, into our BP third person character because we added a function to this class for just this reason. And function override update interaction text. So we're going to do that there. So interaction actor valid. So as long as this is valid, which that's the same as is this a null pointer? If it's not valid, one way. If it is valid, we want to do something else. So if it is valid, we want get interaction. Okay, why that's no. Okay, why is it not giving me the interface function? What is that called? Get interaction text. Okay, why is it not giving that to me? So, no, we want get interaction text. Cast direct foliage, add interaction. Apparently that's not even in the blueprint library. What? Because it's right. It's a function, get interaction text. Okay, this is weird. Interaction. No. Did I miss making that a blueprint callable function by chance? Interaction interface. Blueprint native is interactable. Get interaction text. It's right there. Well, let's see. New function blueprint callable. I think that's actually going to cause an error when we try to do that, but this is not making sense to me right now. Let's get rid of the content browser. Let's try a live code event. See what it says. Build failed, missing, new function implementation, function. This function, what? You function. Yeah, that's what I thought. So, why is that not? Okay, that is confusing me. However, we're going to do just something. Cast to BP door base. And let's just see. I just wanted to see if this would get interaction text. No, text. Context sensitive. What is going on here that these are not? Graph is not editable. Did I screw something up in the door class? No, because it's interface, get actor idea. That's it. Those are all. Yeah, those are all expected. Let's just. Okay, this is a little weird. It's not letting me call that interface. contents available there. Okay, let's put this back to context sensitive, git enter. Why? Maybe it's because it's a live code. Let's just save this. We're going to close out of all of this. Something is going on here that doesn't make sense, because we do have this function here that should be accessible and should be callable through blueprints. So let's rebuild everything here, make sure this is all working. And while this is building, just as I mentioned, and I've mentioned several times throughout the series, this is the sort of oddities I want to leave in so people can see the troubleshooting that goes on and what sort of things you need to look for and potentially what things you need to do. Because again, I found debugging tends to be one of the things people struggle at the most. Like, they write code, it works once, and then they're like, okay, why didn't it work a second time? Why didn't it work a third time? Things like that. So okay, no, I don't want to move or copy. I clicked and then dragged and I thought I wanted to do something. So let's go third person blueprints, third person character, open this up, git interaction text. Okay, did I type that in wrong? Because this is making zero sense. Git interaction text. Okay, I'm going to copy that. So in the editor, I'm going to right click, paste. Give it context sensitive. What the hell? Cast to BP door. We do not want to do this. This is just me troubleshooting. Get interaction text isn't there. Yeah, I know. Let's move out of there. Let's go back to our door. Interface, get interaction text. I'm just going to put debug. Okay, let's go back here. Get enter. What the heck? Graph is not editable, is interactable. No. Get interaction text. It's not even exposed to itself. Not marked as blueprint callable and cannot be placed in a graph. Did they change that with 5.4? Close and close the editor. Blueprint native event. Blueprint callable. Because I always found previously blueprint native event just made it so that it was blueprint callable. Or is that get interaction? Yeah, I'm not overriding anything there. Oh, okay. That is new. I will have to go through and fix a bunch of other calls then. So let's see if that actually makes a difference here. So that is a change that happened with 5.4. It's the first time I've been writing interfaces with 5.4, at least like this. So obviously I missed a very critical part. So we'll open up the door blueprint again, and we can do this really easy. Get interaction text. Come on. Thank you. Drag you over. There we go. Okay. That would be why. Compile and save, just because we made some changes here. And we're going to go back to our player character. Don't need that cast anymore, so get interaction. There it is right there at the top. Wow. So again, an example of here's a problem you run into. Why isn't it working? Well, there we go. Because it can be both Blueprint native and Blueprint callable, which seems a little odd that you have to add both, but also makes sense at the same time. So we're going to do that. Now, what we want to do quickly is, I'm just going to close out of this. In our very basic UI, we want to add some text. So we're going to, in our canvas panel, we're going to add another stack panel. I'm going to call this stat bars. This one is going to be action text. This one is going to be anchored into the center. We have X is 100, so we want minus 50 and minus 15 to keep it in the center. Text block. Let's see, text block, we want this to be blank, is a variable, and action text value. And then what we want to do here is go into our graph. We want to, in the function, we want to click the plus sign and set action text. We want to give this function an input of f text, but we're going to say new text, f text. Don't need the f here, so we want text. And then where is action text value? Set text. And for ease, actually, I'm going to add another one, a Boolean value here of b show text. And what we're going to do here is branch. Actually, we don't even need a branch. Set visibility. Select. We're going to pull off the show text. So if it's true, it's visible. If it's false, we want it hidden. Compile and save. Go back to the designer, pick our text, and then visibility hidden. So we want it hidden by default. And then, so we're going to go back to our player character. And we need to do something with that original create widget logic we put up here. We're going to drag this over to the right, the add to viewport, right click on the return value for create dev basic HUD on the actual value, promote to variable, and R game HUD. Now the R here is just to indicate that it is a reference. We're going to change the flow path to here. We're going to remove that by clicking Control, drag that, and connect these two pins to set it up so that we're saving a reference to it, and then we're adding that reference to the viewport so that down here we can go game HUD, set action text, and we can have one go down here. We're going to duplicate this and go up here. And I'm going to set this to true. So just quickly to explain a couple of things in this. So what we're doing here is if we do have a valid interactable actor, and that is the one that we're hitting with the line trace, we're going to go through this flow path. It's going to grab the text from that actor, and then it's going to pass it through to our HUD, and we're saying show. If it's not valid, which means we're not hitting something, we're going to go down this path. We're setting the text to a empty value, not null, but empty. There's just nothing in there, and we're hiding it. So we're going to compile and save that, and I'm actually going to throw a breakpoint here just so that we know. Actually, no, we don't want to do that because that's going to, the first time our line trace hits the floor, we're going to throw it there. So I'm going to just save that quickly, move this out of the way, move the content browser out of the way. Thank you. And we're going to try this again. And as soon as that breakpoint's hit, I'll bring that blueprint window back over. So we're going to run over and see our line trace starts again. I'm going to jump up. Oh, well, we're not hitting that. Why is that not happening? So let's go back to our blueprint. Again, troubleshooting. So this is the update interaction text. So let's go back to our code, to our first player character. So update interaction text, I know exactly why. We're not actually calling it here. Oh, update interaction text implementation. So we want to call that in both cases. Actually, we can do that in a much more refined single point case. And just add that up here. Because we're happening both of the subsequent code flows, either if we're going through this if it failed or if it didn't. We're updating the text. So we'll just add that there. And that, so update interaction text implementation, that's calling down here, which is calling to the blueprint native event. So let us go back to the editor, move this out of the way again, do another live code update. So, and this is where the live code updates are useful. You realize you've made a minor mistake. You want to make sure that is going to fix the problem we're seeing. You make that minor code change, you run a live code edit just to make sure. And then, okay, let's run here. So hop up here and let's see. There we go. We have hit our breakpoint this time. So we have a valid actor, which is the BP door. We're going to step over and we've got a value of debug. So we're going to just continue, get rid of that. Yeah, and that's getting hit every time. So we're going to want to find a way to refactor that, but we'll do that a little later. So continue, and you can see there it says on the screen debug. So we're going to stop there. We're going to fix that so it's no longer the debug message. To do that, we're just going to open the door blueprint that we created. Bring this back over here. We're going to get interaction text. We're going to do a select text is open. So if it's true, we want it to be closed. If it's false, we want it to be open. Compile and save. And just for those wondering, save and compile. I have it save as long as the build was compilation was a success. So we'll try this again and we'll just see. Hopefully this says open and close. So run up, we see our trace, it says open, it says close, open, close, and it refreshes whenever we do the interaction. So the reason for that is being updated on every line trace. So with that, we do want to find a way to improve that so it's not calling this function every single time. But what we're going to do here, we're going to make sure everything is saved. I'm just going to do a save all. You can see down here in the bottom right of the screen, it says all saved. There's nothing to worry about. I'm going to close the editor. Live coding is going to fail. I'll fail, close out. And we are back into Visual Studio. So a couple of things we're going to do here. I'm actually going to comment out. Actually, no, I'm going to add in a debug control for this. We're in the private section, right? Yep. So edit anywhere. Bool debug show interaction trace equals false, and we're going to change this category to debug. And then over here in the player character, if show no, debug show, is that what I called it? Really, my brain's forgot already. Debug show interaction trace. Go over here, if debug show interaction trace with a single D. What? Undefined. Or is that just too big? Oh, semicolon. Wow. So if debug show interaction trace, so if that is on, so that is just something you can add in that allows us to, while in the editor, turn on and off the debug trace. Sorry, brain wasn't working there. So anyways, we wanted to go through and refactor the update interaction text use. So it's this one here. So how could we do that? So if it's not a blocking hit, or it doesn't, we want to do that there. Yeah, ultimately, I don't think there is a way to easily do this. You could go through and add some checks and balances of, okay, we need a variable to store the current text. We need a variable to store the current, or I should say a variable to store the interaction actor that is being displayed. Ultimately, that starts becoming a memory management issue where, again, we're talking a minuscule amount of memory. But as I've mentioned before, this adds up. These small little bits here and there all add up. As the old saying goes, it's the straw that broke the camel's back. Things get added on, and when you start using the approach of, oh, it's just a little tiny bit here, it's not a big issue, you tend to start doing that everywhere, and it tends to result in, well, real bad memory usage. And honestly, looking at the code I've written here, it's already not the most efficient in memory. So ultimately, though, this particular case of once per frame we're calling this, I think the benefits of it outweigh the negative impact. It's very minuscule. We're casting to we're calling to an interface. We're not even casting so much. And from there, it's going, okay, grab the text, throw it on the screen. Whereas the checks and balances that would need to be done to not call this every frame would probably actually be more resource intensive than doing this every frame. So with that, though, folks, I actually think I'm going to end this episode here. We are actually finished up a little quicker than expected. And I know last episode took a little longer than expected just because of the problems we were having. So one thing I'll do before we'll run the editor one more time just to make sure this change here actually works. I know my naming convention of the all capitals with the underscore space separator is pretty abnormal. However, the whole purpose for that is it needs to have a very glaring name so that it jumps out at you as like, oh yeah, this isn't something I should be messing with, or I should be however you want to look at it. So, okay, our build was successful. Let's launch the editor quickly. And this is going to take, hopefully, not too much time. All right, there we go. So let's play. And we have that variable set to edit anywhere. So we should be able to just go character, third person character. And we should have in here, and this will be where we start putting all of our, actually I'm just going to type debug, show interaction trace. So let's make sure this works. We'll go over, trace is there, shift F1 to get out, turn that off, move around. I know why. We're turning it on, but we never turn it off. So that is why. Let's close out, and we'll fix that quickly. When none all line traces where the trace tag match will be drawn. Let me just double check this one. I don't want to throw out some half-hearted attempt when I'm not 100% sure. So we want UE5 C++, turn off line trace. Disable blocking collision, enable disable input, turn off line trace visualization. That's the one we want there. Communities popping up. So, and for a lot of people, this may seem a little weird, but this is what a lot of programming is. It's like, I'm not 100% sure how to do this. Google it. Get world line tracing. Okay, it seems a little all over the place. So here, let's just if else get world debug line trace debug draw. Helps if I get rid of my spelling mistakes. Draw trace tag equal, well, none. Oh, okay. Equals text. That's what. None. So we can actually filter that even easier. And hopefully this should work. So this is where sometimes it pays to literally just hover over something and read the description. Not everything within Unreal and a lot of code have this, but as we can see here, if I'd actually read it, the first time I hovered over it is when none, all line traces where the tag match will be drawn. So this should clear out that extra semicolon just because it's not needed. This should fix our issue. So and this is actually turning almost into a full-length episode again. So all right, so that build went through. And actually, there's one other thing I'm going to show you guys just because I've seen it there, the logger. We did hit that a couple of times, so we should have some logging created. I'll show you specifically where to start looking for that during a like Visual Studio launched editor. Okay, let's just play. Okay, let's go through. We're going to run over here. Okay, you see the line trace isn't working. So character and debug. I'm going to show that. Start showing. Turn that off. There we go. So we added in that little flag so we can turn that on and off while playing. That way we can see, oh yeah, we hit this object. So let's make sure everything else is still working though. It is still open. Close. Door moved too quickly for me. There we go. So that is working there. Now, as I was just saying, we will take a quick look for our logging. So we're going to close out the editor because everything is working there. So right click, open folder in File Explorer. I'm just going to make sure, I'm pretty sure this is where it is. Actually, what did we call the file? So I know what I'm looking for. tflog underscore. Oh, I think that actually goes to the engine. Tflog star dot star. Sorry, just I know I'm doing things off screen here with that. What I'm doing is I'm just doing a file search, but just for the interest of, well, keeping myself my stuff private, I am doing it off screen just for my own sanity. All right. Yeah, why am I not finding this? TF log star dot star. I'll do one final check on my other hard drive. There's only 3 hard drives it can be on, so. Okay, well, this is taking a little bit of time. I'm actually going to pause things, and once I figured out where it is, I will be right back. All right, folks, so it did take me a little bit to track it down. Let's close that out. So it is actually, because we're using the editor, it is in a bit of a weird place. However, so with that, it is in where you installed the version of your engine in the engine folder. Go back, binaries. So engine, binaries. In this case, because I'm running on Windows, Win64. And then it is, in this case, because it was tflog, so abcqrsts. Scroll down. tflog. And there you can see that was for today, July 9th, 2024. We open this file up. I will just bring this over, and you can see there is a bunch of the error messages for failed to cast to interaction interface. So this is a sample of the log that we created a couple episodes back. So with that though, folks, I have nearly made this turn into a full-length episode. We have finished up the basic interaction component for this episode, and we will be moving on to, I actually don't know what's going to be in the next episode, so I'm going to spend some time thinking on where is the next point to go. We have a couple of different ways we can go. We could go through things like a day-night cycle. We could go through inventory. We can go through something I want to include in my game, thermal concerns. So that's like ambient temperature. I'm going to think about that. There's not enough of a community right now for me to worry about throwing up a poll. However, next episode will be something along the lines of one of those options I just mentioned. So, thanks again for watching, everyone, and I will catch you in the next episode. Hey there, folks. Welcome back. So, this episode is a bit of an impromptu one. It's just while I was doing some troubleshooting with the project after the last episode, I did notice there was something that wasn't working properly, and that was our door. It wasn't actually being saved properly, and as a result of that, it wasn't being loaded properly. So we're going to work on that quickly this episode, just to get things sorted out there. So, just a little bit of background before we go through. So we're looking at our door base class here. It's derived from TF actor, and if we go look at TF actor, it includes the iSave interface. And apparently it's it's still doing its parsing of everything. Because apparently fgood isn't valid. With that though, we'll just let this continue parsing quickly. I thought I'd left this run long enough, but part of the reason why is we don't have all of the save interface fully defined. If we look into TF actor source file, you can see we just have the very basics. We're not actually returning any save data, anything like that. So there's no actor transform or anything like that. Stuff is getting reset back to its or like to the origin of 00. So what we're going to do here actually is go into these header files. We're going to just copy these three here, and this is the header for TF actor. We're going to go into the door base header, and we're going to copy those, and we're just going to do override on the end of all three of these. And okay, just because part of my workflow process, we do need IntelliSense not to be throwing all these errors, I'm actually just going to pause the video here quickly, and once IntelliSense is finished parsing everything, I will be back. Alright, so it finished doing all of its parsing and everything. Well, parsing that was affecting the project. Set actor good implementation. Doesn't override base class. Okay, we don't need the override there. So we're just going to quickly create these definitions. And then populate the data. So we want to return a save actor ID. Save ID? What do we call it? TF actor base. Oh, that's why it is a private one. So this is why, again, I like to go through and have things properly laid out. Let's get these cleaned up. Get rid of these comments. Just because it makes things work. New property visible anywhere, and apparently I didn't wait for this to finish loading. Blueprint read only. We don't need this, and I want to put a private tag up here. Save ID. Okay, so we're going to go back to our door, return save ID, and if save ID is valid, save ID dot invalidate, save ID equals new GUID, and then f save actor ret dot actor transform equals this, get actor transform ret dot actor class equals, it's not a function, this get class. Now most of this we'd actually be able to do. Actually, we don't even need to do this here, so let me fix that. Well, I'll just finish it off here and copy and paste it. So we don't need to do byte data right now. We have no components, and was spawned. We can, I'm just going to default this to false for now. However, we are going to add a variable for that. So with that, because we're not doing anything specific for the door, we can actually do this back here in tfactor. So I'm just going to do that. And then we need to add a bool was spawned, or actually b was spawned equals false. And then that equals this b was spawned, and return ret. Alright, so get actor save implementation. Alright, that's fine there. We can get rid of this one. Let's add that to tfactor as well. We already did, and we already did. Okay, so we can actually clean these up. We don't need the save interface functions within the door. The reason why it wasn't working is we hadn't actually defined anything here. And we can remove these from the header file for the door as well. Now we do have this brain's not working. This variable here, which we are storing, and it should be part of the save game. So this should serialize when we run through that. And we'll debug step through the save game logic in the game instance. Really annoying how these constantly say you can't include core minimal, no such file exists, all of this, but they're qualifying on the function. It's because none of this is compiling properly. So I'm going to close out of the door. Do we need to close out of this? Actually, I want to add in a U function blueprint native event void update from save. I think, actually no, we'll leave that for now. So what the whole purpose behind this was going to be is when we load the game. So actually let's go to our save actor interface here a second. No, I don't want to rename it. So it would be get component again, set component. Actually, yes. So that is what we want to do here. It's a function that we never added. We're going to add that in now. Of get actor ID, set actor ID, get save data, get component data. Okay, so it's in here. So we're going to copy this for the U function and void update from save. Now, do we want to? No. Void update from save implementation. Now we need to grab this, and we're going to need to go through and add this to our header file, just so it has the definition. And then we're going to need to add that to a couple of different places in the code. So the first place we're going to want to add that is to our tfactor. And actually what we're going to do here in the save interface, we're going to call the default update from save. So if it's not implemented at a code level, we're going to push it through to a blueprint function. Now we're going to expand that. And we're going to just do update from save again. So the reason why we're doing this in both the save interface and the tfactor implementation of it is simply because in here we're probably going to expand this further on. Non blueprint logic goes here. So the reason for this is there's certain things that work a lot better in blueprints than they do at a code level. And that'll be things like opening the door, stuff like that. It's because everything's defined with that timeline, it's a lot easier to just also do that in blueprints as well than it is to try and do it at a code level. So what we are going to do now is from save. It's the game instance we need to expand here. So I'm just going to close out of all these. This is the other reason why I do recommend you keep your files and folders as organized and as clutter-free as possible. You don't have all the stuff open there. So let's open up our game instance source file. And then what we're going to do is go to our load function. No, not set player data, load game. So in here, we're going through, and just to cover this again quickly, this is our spawned actor information. We're just chucking him into the world. That's all we're doing there. Now down here, when we're actually going through and applying the save data, and then right here, we want to go inter.update from save, and this is going to throw that error we've seen in a previous episode because we're not calling execute. So what we actually want to do here, I'm going to leave that there for reference for now, inter.execute update from save, and then we're going to get rid of that one. And in here we want to pass in, as we found in the previous episode, a reference to actor. So, and then just make sure we don't have, I suppose that one didn't throw an error. Anyways, so we are going to build this quickly. Now let's see, this may take a little while because I was in a couple other projects in the time being. So I will pause the video here and I will be back once the build is done. Alright folks, that build's finished, so let's launch into the editor. And this should hopefully not take too long. I was going to do this before I restarted the video, but honestly, I forgot. And because I forgot, it's deciding it's going to take a while. So I'm going to pause the video again real quick, and I'll be back once the editor is open. Alright folks, we're back and the editor is launched now. So with the editor running though, one thing we do need to do quickly is hop back over to Visual Studio and add some additional breakpoints. We don't need the player data, we know that's working. So we're going to throw a breakpoint in just here. The reason being for this is right after we have validated the GUID. We know the player doesn't have a valid GUID, but the door should. So we're also going to do the same thing down in the load game. It's going the wrong way. Factor. We're going to throw it in. Actually, we'll do it. Leave it right there. So back into the editor, we're going to click play. Going to just move our character over so we know that we're loading and saving properly. Stand here. Actually, I'm going to face the door. We're going to hit 7 to save the game. Okay, BP door base, we can see is the actor we're loading. So get save actor data. We can see we've got our location rotation, was spawned false. Right now we can see the byte data is empty. We're going to just serialize. I'm going to take a quick look at that byte data again. Don't potentially see. I hate how that doesn't actually show you anything. And this is just going to go through all our components, so we're going to just drop through to there, take a quick look. Hopefully one of those is that value. Component is, yep, all that looks good. So we're going to just drop it there, and component, what are we in? Gather player data. Oh, we don't need that information, so we're going to continue from that. So we're back in the game now. And we'll just move over to the other side. We'll face the door. And we're going to hit F9. Okay, we are on the door base. Take a quick look at the information. We have the actor transform. The byte data does look like there might be a problem there, but we're going to go through. That just could be because it's been serialized. So we're going to deserialize, and then I'm going to step into, we didn't. Oh, we're calling the, yeah. But now you can see the door is still there. Previously, when I was doing this, the door would actually disappear because it moved to the 0, origin. And we're going to hit save again. This time I'm just going to, actually, no, we want that. Let's take a look. Does that, nothing. Oh, we'll wait till the serialize. Now let's take a quick look. Okay, now B is open, is there. So let's continue. Okay, now let's see. We'll move over here. Actually, I'm going to close the door, and then we will load, and we'll see if that state changes. So close the door. Actually, it won't because we didn't do any of the blueprint levels. So we'll hit F9. It's going to continue. Update from save. That's probably because we're calling it at a code level. But yeah, we didn't do anything there. So let's stop. And let's actually fix that missing function that I forgot to add in there. So we're going to open up our door base blueprint. And it opened up on a different screen. Let's pull this over here. So go to our event graph, interfaces, and update from save. B is open, Git is open, branch. Now you have two different ways you could do this. You could, if you wanted to, go to your timeline and reuse that. However, if we open this up quickly, we know it's either 0 or 110. So if it's open, go back to the event graph. We're just going to copy this, paste that. Actually, we don't even need the branch. So we're going to do this. We're going to go select, float, move this in here. So if it is open, we want this to be 110. And if it's not open, we want it to be 0. And we're going to connect that. Compile and save. Now let's try this again. Now we should be able to just load. And we're going to get that error again because we're calling a function that we shouldn't be. I'll fix that in a second. But there you go. You can see it opened the state of the door. So now that we've done that, let's just make sure everything is saved. It does say all saved, but I do like to just click that to make sure. The other thing you can do, obviously, is file, save everything. Apparently my editor's being really slow. Save all, or use your standard Control-Shift-Fs. So now we've done that, we're just going to close out of the editor because we don't need that open. And we're going to fix this mistake we have in here. So close out of the map. We don't need this. We don't need the generated. So what that is going to be is more than likely, actually I want to leave that comment, this little section right here. Execute, update from save. And pass in this. And we're going to just comment that out. actually, I'm going to do a Control F, find all in current project, and just make sure. So this is another way you can go through. So we've got that commented out. Let me do that. I'm going to leave that one there. I don't think that is the error. And then that's that. So let's do a quick build, and we're going to try again on this, and we'll just see if that fixes that error message. So build really quick, because all we did was make that one line code and change, and the editor should launch very quickly this time because we were just in it. Yeah, it's already at 80%. So all right, there we go. And we are literally just going to hit play. And again, because we're using those GUIDs, we are not using a GUID on the player character, or and it's a static one that's already there on the door. We should be able to just hit F9, and we load everything in. And you notice there was no error this time. So let's try that again. F9. Oh. That should have been stored as open. So let's, or did we save with it closed? So we'll hit F9. Oh, it's not happening. So let's go F7. Continue that. F9, that's staying open. Okay, so let's close it. I'll have F9, just 9, and then 9. Okay, so that worked. Might be something to do with the save. So let's drop out. Let's run again. Pressing 9. Hit open. Well, that might have just been a quirk because we made that change. So with that though, this is going to be a shorter episode. I just wanted to get that one. I don't want to call it a fix. It was really more we missed something in the last episode to get the interaction system there correctly hooked into our save game. So that's it for this episode, folks. I know in the last episode I said I wasn't sure what was going to be the next episode. I'm still not 100% sure on what is going to be the next main focus. I did actually end up throwing up a poll on the channel, but we're still early in the channel's life. Don't have many subscribers, so I'm not expecting much there. I did put my personal preference as a vote, which is the inventory system. However, I will respect whatever the final vote is once I get around to recording the next main episode. I think I'm actually going to record probably a couple more of these sort of little one-off episodes because there's a few other things I'd like to do, and then we'll go from there. But anyways, folks, thanks for watching, and I will see you in the next episode.